In this video, we will be writing piecewise functions given graphs, and we will be doing a little bit of analysis as well, and we will be evaluating piecewise functions. So that's what's happening. Now, number 7. So this is a multiple choice question where we're supposed to match these piecewise functions to the graph. But what I sort of encourage you to do is just ignore these choices for a minute. Forget about those. Just look at the graph and make your own piecewise function, and then you can look back and see which one was right. So that's the baller way to do it, so of course that's the way I'm going to do it. So when you're making a piecewise function, you start off like this, f of x, and you do a single brace like this. Okay, don't feel bad if your braces don't look as beautiful as mine. I've had 25 years to practice for drawing these braces. Anyway, I'm going to look at this, obviously this is an absolute value function, but we need to look at it as a piecewise function. So let's see, let me do a little tracing. So this is going to be my blue side, and this is going to be my red side. Okay, so I need an equation for each of those. So let's start with the blue side on the left here. In my mind, I'm thinking about y equals mx plus b, all right, because this is clearly a line. So I need the slope and I need the y-intercept to write this. So the slope is going to be easy because it's going up 1 over 1. That's the slope. Notice this is positive. Don't think this is negative because this arrow is going down. From left to right is going up. Uphill, downhill. Positive, negative. All right, so this side over here is going to be a positive x. Now, I need the y-intercept. Now, you can't see where this, this blue segment, this blue ray, does not actually touch the y-axis at all. However, what we're doing is we're talking about the line that contains this ray. So the line that passes through this ray goes forever. So if I want to see where that line crosses the y-axis, I am going to continue the line in that direction. So going from left to right, this is going up 1, right 1. So starting here from the vertex, if I kept going up 1, right 1, well, right away it's going to hit at 4. So that would be, and it keeps going, but so this would be my y-intercept, would be 4. So this would be x plus 4. And then if x is, now my axis of symmetry is right here. All right, this is the line going straight down the middle. Okay, and that axis of symmetry is x equals -1. All right, so all of these x values on the blue side are to the left of -1. So I'm going to say less than -1. So that's it for that. So now I'm going to do the red side. Now this is going down 1, right 1. It's going downhill, so the slope is -1. So I'm just going to put -x. Now the y-intercept for this piece is obvious because it's right here. Okay, the y-intercept is 2. So I'm going to put -x plus 2. These values are to the right of the axis of symmetry. So I'm going to put x is greater than -1. Now one of these should be or equal to. But for an absolute value function, it doesn't matter which one it is. So I'm not going to draw it in yet because I've got matching to do. And if I pick one of them and make it or equal to, if it's the wrong one, I'm going to think I'm wrong, and I will actually be right. So basically, ignore which one of these has the or equal to sign on it, because it doesn't matter. So other than that, let's match it up. Well, C and D both have a 0, okay, for the point of change, for the domain restrictions. So it won't be C or D. You can forget about that. So these have the -1. So let's see. X plus 4 if x is less than -1. And then, so that matches the blue. -x plus 2 if x is greater than or equal to -1. Well, if we choose this one to be or equal to, that's a match. So the answer is, in fact, A. Kabam. Let's see. The top equation matched the blue over here. But yeah, so here's the problem. They have -2, x minus 2, instead of plus 2. So this is the reason why this one is wrong. All right, so the answer is A. Okay, now let's move down with our analysis. Which is not true about the graph below? Let's see. The y-intercept is 0, -2. Let's see, 0, -2. That is the y-intercept. So we're looking for one of these that is not true. So that means A is not the answer, because that is true. The x-intercepts are -6, 0, and 2, 0. Or you know what? Those are the x-intercepts. So that's not the one that's false. The axis of symmetry is x equals -2. X equals -2 would be right here. But you know what? That is the axis of symmetry. So, skirt. So this must be the one that's false. So what's up with it? The range is from -infinity to -4. Yep, that's the one that's wrong. Okay, the range should be from -4 to infinity. All right, so that's the one that's wrong. Okay, evaluate the function at the indicated value. So you have to pay attention to the letter. So this says g, so I need to be looking at function g right here. Now, these are x values, all right? So this is an x value of -4. So we're going to plug it into one of these x values. Only one of them, not both. So let's see. The domain restriction will let us know which one to use. So -4, is that less than -1? Why, yes, it is. So that tells us that we're going to be using the top part of this equation. Okay, so that tells us that we're going to be doing, so x minus 4, so that means -4 minus 4. And that equals -8. So that should be -8. All right, let's go again. F. All right, so function f, so we're talking about this function. 3. Is 3 less than 0? No. Is 3 greater than or equal to 0? Yes. So this tells us that we're going to be using this portion of the graph. So we're substituting 3 in for x, so that means 2 times 3 plus 1. So that's 6 plus 1, so that is 7. Awesome. Okay, number 11. It says function h, so we are here. We've got 2. Now, 2 is mentioned in these domain restrictions. So which one do I use? Well, this one says you use this one if the x value is less than or equal to 2. And this x value is equal to 2, so that's why we're going to use this one, which tells us to use this top portion. Okay, so that would be 1/2 times 2 minus 4. Half of 2 is 1. 1 minus 4 is negative 3. So that should be negative 3. All right, so that's how you evaluate. And last question, let's write a piecewise function for this graph that's pictured here. All right, so this is going to be almost the same thing that we did right at the beginning when we did problem number 7. It's almost the same. Okay, so we're going to start off with our f of x and our brace. Okay, this will be my blue function. You know what, I'm going to... All right, so I've colorized this, and so I've got my blue piece and my red piece. I need an equation for each. So let's start with the blue piece. In the back of my mind, I'm picturing the model of y equals mx plus b, because I can see that these are straight lines. So I need the slope and I need the y-intercept. I'm looking to see where this piece hits exactly on the grid lines. So I'm putting some extra dots on here. So now that I've got these dots, I can do my rise and run. So up 3, right 1. So that's 3 over 1, so that's 3. So that's why I'm going to write 3x, because I know the slope here is 3. Now I need the y-intercept to go here. Now if I continued this, all right, up 3 over 1, up 3 over 1, up 3 over 1. It's going off the graph, but I'm pretty certain that it's going to hit at 13. Is going to be my b value, 13. All right, now if I wasn't sure, I could do a little y equals mx plus b analysis. All right, so here's how I could find the b value, even though this is kind of going off the graph. Using my y equals mx plus b, I need to pick a point to use for my x and y. This point right here is a good one to use. I mean, you could use any of these points, but why not use the end point? So this is the point, let's see, negative 3, 4. Okay, negative 3, comma 4. So negative 3 is my x, and 4 is my y. Okay, so since 4 is my y, then this becomes 4 equals. Now m is my slope. I already know that's 3. And then x is negative 3 plus b. So this is 4 equals negative 9 plus b. So now I'm adding 9 to both sides. And sure enough, I get 13. So b is equal to 13, just like I thought. That doesn't look like a 13. b equals 13. So that's why this will be 3x plus 13. Now if x is what? Now notice this is going to the left from here. Now the line I'm about to draw right now is not called the axis of symmetry, because these pieces are not mirror images of each other. So this is not symmetry that is happening. However, this position, all right, this line x equals negative 3. This is where it changes from the blue graph and it jumps over to the red graph. All right, it changes at an x value of negative 3. So it is the blue graph when the x values are less than negative 3. It's the red graph when the x values are greater than or equal to negative 3. Notice I said less than, because on the blue graph, this is an open circle, so it's not allowed to be negative 3. So that's it for the blue piece. Now the red piece. If I were to start putting dots on here, there'd be nothing but dots. Okay, it's all dots all the time, because this is going up 1, right 1. Okay, so that is positive 1, x, so I'm just going to put x. Now for the y-intercept, I don't have to do anything actually at all. I started to say I could just look and see where it crosses the y-axis, but it actually crosses here at 0. And so it would be silly to put x plus 0. So really all you need is x. Okay, so if, and we already spoke about this, x values are greater than or equal to -3 because these x values are going to the right. And that's it. That's what this piecewise function should look like. Notice that both of these slopes were positive. They're both positive, +3 and +1. And that makes sense because look at these lines. The blue line from left to right is sloping uphill. All right, that is an uphill line. That is a positive slope. And then the red line, okay, also sloping uphill. All right, from left to right, uphill, uphill. They're both going uphill. They should both be positive slopes like this. All right, that's going to do it for this video. I hope it was helpful, and I will see you on the next video.